So we're doing chapter 9, question 14. I just completed part A. There is the eye spots have a significant influence is what we found. Now we're going to compute the estimated Cohen's d to measure the size of this treatment effect. To calculate Cohen's d, we are going to need the standard deviation of the sample. We are going to need to have also the mean of the sample and the population value. What that means is, well, I erased some of my work, so I'm going to have to do it again. But it also means we're going to have to go back and calculate that variance because I don't have it written out, and calculate a standard deviation from that. So if we're calculating estimated Cohen's d, the formula for this is the mean, subtract the population value, divided by the standard deviation. But we don't have that. We have sum of squares, and I already erased all my work, didn't write it out. The variance needs to be calculated. And we had variance instead of standard deviation, so we need to go a step further anyways. So standard deviation is equal to the square root of the sum of squares divided by n minus 1. N minus 1 because we have a sample, not a population. So this sum of squares, this was 210. And our sample size is 15. Subtract 1, so we have the square root of 210 divided by 14. 210 divided by 14 is 15. So we need the square root of 15 because we need the standard deviation for our formula. So we need to take the square root of 15. And there we get 3.87. We'll keep 2 decimals, that'll be sufficient. So up here in the estimated Cohen's d, and it's estimated because we're using the sample standard deviation rather than the population value. We're going to take 34.5, subtract 30 divided by 3.87. So that gives us 4.5 divided by 3.87. Divided by 3.87 is 1.16. In terms of how large or small of an effect size this is, recall that a small Cohen's d is 0.2, medium is 0.5, and a large is 0.8. Our number that we calculated is bigger than 0.8, so this is a large effect. And it is important for you to not only be able to get the numbers, but know what the numbers are telling you. What do they mean? So it is important for you to be able to understand, okay, this is a 1.16, that's a large effect. That's a large Cohen's d.